Okay, functions. Today we're going to be looking at functions, and I'm going to make sure I can try to explain what a function is in the simplest ways possible. So we've all looked at things like y is equal to x plus 3, or maybe f of x is equal to 3x plus 1. So all these are what we call functions. But what is the actual definition of a function? A function is a set of ordered pairs, and this set of ordered pairs is such that every pair has only one first element. So I know this can be a bit abstract or weird to understand for the first time, but I want you to look at something like this. This in the simplest way is actually what a function is. So we have two differences, that is 1, 2, 3, 4. So now we can put a relationship between these two sets. This set I'm going to call it the domain, and this set I'm going to call it the codomain, or what you call the range. So there's going to be a mathematical relationship between these two sets. That is, I can take the relationship such as y is equal to x plus 3. So every single element here is going to be mapped to exactly another element which is plus 3 more than that. So this is going to be 1 plus 3, which is 4, 2 plus 3, which is 5, and 3 plus 3, which is 6, and 4 plus 3, which is 7. So this relationship here is actually what you're going to call a function. And these numbers, 1, 4, 2, 5, or this is supposed to be 2, 5, then this is 3, 6, and 4, 7. This set here is what we call a function. And every single one of these elements is only appearing once. Every single one of these first elements is only appearing once. So it means if I was to have, let me say, a visual interpretation of that, it's something like this. All these different ones here. All these are functions, because exactly one element here, that is let me say a 1, is mapped to exactly another one element here. This is actually the line y is equal to x squared, and this is also another random continuous increasing function. So we have exactly like one element here, let me say 2, will be mapped to exactly one element here. So again, one element here is mapped exactly to one element here. So let me say it's 2, it's mapped to another element, let me say 4, by some relationship here. So if something does not follow that rule, whereby we have one element being mapped to one other element. So the reason as to why I bring this up is because I wanted to show you that a circle is actually not a function. So let's take the most elementary circle, that is the unit circle. I'm going to take x squared plus y squared is equal to, let me say 4. So this is this circle here, with its center here at 0, 0, and with a radius of 2. So what happens is that if we are taking the x, y, this is x, so we are taking the x as the domain. So the domain has, if you take one vertical line, let me say y is equal to 1. So if you take this one vertical line here, realize that it maps one x element, which is the 1, and it maps it to 2 y elements. So it maps it to these 2 elements here, meaning that mathematically, a circle is actually not a circle. A circle is not a function. Okay, so now after talking about functions, I wanted to look at a small thing of how to determine the domain of a function. Now remember that a function can only be a function if it has a rule and it also has a domain. For instance, if I'm properly writing a function, let me say y is equal to x plus 1, I'll have to add the domain on which it is defined. That is, it's an element. Every single x element is an element of the real number set. So this is defined on the entire real line, meaning it is a okay, most of the polynomials is actually defined on the entire real line. So let's say I want to look at a number. Let me say like y is equal to the square root of x squared minus 1. So now this is y is equal to x squared minus 1. We want to define this function properly. So it means we shall have to give it a domain, right? So now, how do we find the domain of this? We're going to make sure that this thing does not become a complex number. So we make sure x squared minus 1 is greater than or equal to 0. So we realize that we want x squared minus 1 to be greater than or equal to 1. So x squared is greater than or equal to 1. We put the square roots and we find that it's going to be x is greater than or equal to plus or minus 1. Yeah, but shit, have I cooked myself? Greater than or equal to negative 1. Actually, this range or these numbers also include the numbers x greater than or equal to 1. So it's as good as taking x is greater than negative 1. But anyway, so if we take x is greater than negative 1, our function is going to be defined for y is equal to the square root of x squared minus 1. That is from negative 1 up to positive infinity. This is negative 1 inclusive. Yeah. So that is how we find the domain of a function.